always believe house. Today we're going to continue factoring. We're going to factor special cases, and I'm going to show you what that means, okay? So let's go over here to the right, and we're going to write down what the special cases actually mean, okay? For instance, let's do 3x plus 2 times 3x minus 2. This is called a difference of squares, okay? So you have the same binomial, but the signs are different. So let's go through and do the full. So I'm going to draw my arches. I'm going to write down my 3 blanks. 3x times 3x is 9x squared. Positive 2 times negative 2 is a negative 4. And then this is going to be plus 6x. This is going to be minus 6x. Notice what happens. The middle term cancels out, doesn't it? So this is going to end up being 9x squared minus 4. Also notice that the 9x squared, the square root of that is 3x in it. The square root of 4 is 2 in it, which is where those parentheses come from. 3x plus 2 and 3x minus 2. Now then, let's work this backwards. Let's do 25x squared minus 9. What's the square root of 25x squared? It's 5x, right? So put 2 parentheses. We're going to have 5x and 5x. What's the square root of 9? It's 3, right? And remember, the signs will be opposite. So one will be plus and one will be minus. So this right here is called a difference of squares. Okay, the middle term cancels out. The parentheses are exactly the same, except the signs are different. Now then, let's go through and do this. 2x plus 7 times 2x plus 7. On this one right here, the signs are, everything's the same, right? Another way you could write this down is 2x plus 7 squared, right? Let's do the full method. So we're going to draw our arches, draw our blanks. 2x times 2x is 4x squared. 7 times 7 is a plus 49. Now then, do the arches. We're going to have plus 14x plus 14x. 14 plus 14 won't go away to 0, will it? It's going to be a plus 28. Okay, so the secret here, square root, you get 2x and 7, right? What's 2x times 7? It's 14. If you double the 14, you get the 28, don't you? So my answer is going to be 2x plus 7 and 2x plus 7. Okay? Oh, and then one more. Let's do 3x minus 5 and 3x minus 5. Okay, on this one right here, they're both negative, aren't they? So let's draw our arches, and we're going to do the 3 blanks, 9x squared, and then we got a plus 25. Negative 5 times a negative 5 is a positive 25. Multiply the arches, negative 15x, negative 15x in it. So on this one right here, the middle term won't be positive. This should be an x. It's going to be negative, right? So I'll get this one out. Now then, to go backwards, let's say this is the problem and you need to factor it. That's a perfect square. That's a perfect square. I could get 3x and 5. 3 times 5 is 15. If I double the 15, I get the 30. So it's going to be 3x minus 5 and 3x minus 5. These are not negative, positive. They're negative because of the middle sign. Those are the 3 special factors. Those are on your formula chart. Okay? Those are on your formula chart. So let's go back and let's use that knowledge and do these. Okay? On the first one, this is a perfect square and this is a perfect square in it. So if I square root this, I get 2x. If I square root that, I get 1. 2 times 1 is 2. And if I double it, I get my 4. Ding, 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 it works, right? So I'm going to write down 2x and 1 and 2x and 1. This middle sign's negative, it duplicates. Or you could write down 2x minus 1 to the second power. This is a perfect square trinomial. Okay, all of these problems like this today on this are special cases. They're like this, okay? A little bit easier than what we did the last 2 days, which was pretty tough. Let's go to the next one. Let's square root. This is a perfect square. That's a perfect square in it. The square root of 25 is just a 5a and then a 1. Is 5 times 1, 5. If you double it, you get the 10, don't you? So this is going to end up being 5a minus 1 and 5a minus 1 in it. Ho, 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 ho. Pretty simple stuff. So if there's a number in front of the x squared term, see if it's a perfect square. This may work, okay? Let's go to the next one. 16 and 9 are both perfect squares, right? So square root, you get 4a and 3. 4 times 3 is 12. If you double it, do you get 24? Yes, you do. So we're going to write down 4a, and the plus drops, doesn't it? And then 4a plus 3. Remember also, you could write this as 4a plus 3 to the second power. That could be an answer choice. Piece of cake. It's a lot simpler than what we did yesterday. Number 7, these are both perfect squares, but the middle term eliminated, didn't it? So the signs are going to have opposite signs. So what's the square root of 9r? It's 3r. What's the square root of 1? It's 1. I'm going to have 3r minus 1 and 3r plus 1. And remember, you could write that either way. You could put the plus first and the minus second, couldn't you? Either way would work, okay? Oh, piece of cake. So what you're doing is you're getting the square roots. Do y'all see that those square roots are going in the parentheses every time? The signs will either be the same or different. Whatever that middle sign is drops, okay? Let's go to the next one. This one, the middle term's gone, right? So this is going to be a difference of squares. Square root. I'm going to get 4x and 5. I need 4x plus 5 and 4x minus 5, don't I? This is not hard at all, okay? If I were to multiply that, I would get my 16x squared minus 25. Continue on. On this one, I have a middle term, don't I? On this one, I have a middle term, so I'm going to square root. I'm going to get 3m, and I'm going to get 5. The 3m and the 5, if you multiply them, you get 15. Double it, you get 30. Ding, 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 it works, doesn't it? That's how you know it works. Okay, so I'm going to write down 3m, and this sign drops. Minus 5 and 3m minus 5. The signs are going to be the same because that middle term's there, right? If the middle term's eliminated, the signs are opposites. I'm going to let you do 13. Number C. Number 21. This gets a little bit harder. Okay? So on 21, you may want to draw a bar. This is where it gets kind of hard. Okay? Not really, but kind of. 18 and 50 are not perfect squares, are they? But they're both even, aren't they? So I could factor out a 2, can I? They both divide by 2, don't they? That's going to give me 9n squared minus 25, right? Ding, ding, ding. And now I have perfect squares, don't I? So what's the square root and the square root? I get 3n and 5, right? The middle term's gone. I'm going to have the difference of squares. So the 2 drops, and I need a 3n plus 5 and a 3n minus 5. Ho, 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 ho. F-U-N, fun, fun, fun. If we only had that taste meter. Oh, 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 oh. Oh, if math problems could taste, I would be so underweight. I would just be doing math problems all day. Oh. Okay, let's go to the next one. 27 and 3 are not square roots, but they divide by 3, don't they? So we're going to factor out a 3, divide by 3, and I'm going to get 9a squared minus 1. And notice these are perfect squares, right? You get 3a and 1, right? So I'm going to have 3 parentheses. The signs need to be, this is a opposite of squares, right? Or difference of squares. 3a minus 1 and 3a plus 1. Remember, you can put that plus or minus in any order, okay? Piece of cake. Let's go to 25. On this one right here, this is kind of tricky because they both divide by 2, don't they? Actually, they divide, by 2, 4. They both divide by 4. So let's divide them by 4. And I'll get 9x squared minus 4. Notice my numbers are smaller, aren't they? So I'm going to square root, and I'm going to get 3x and 2, aren't I? So I'm going to drop my 4, and I'll have 3x plus 2 and 3x minus 2. Ho, 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 ho. I don't want to take all of your Oreo cookies away because this is so much fun. Have a wonderful time finishing this up. If you need help, message me. I'm here for you. Watch the videos again if you have trouble. Remember, you are amazing. You are created to do wonderful things, and you are awesome.